Good evening, ladies and gentlemen. Welcome to our online webinar on Introduction to Nuclear Reactors and Nuclear Power Plants. So I'm Ramalingam Anjuhan, today's moderator for the webinar. Before we start, I would like to thank the RNA, Russian Nuclear Education Ambassadors, for giving this opportunity for us to spread the knowledge of nuclear around the world. So we have an exciting lineup up ahead. The session has three. One is the Introduction to Nuclear Energy. It will be presented by Prabhat Butiga, first year master's students at TPU, Tomsk Polytechnic University. Then the second, Development of Nuclear and Radiation Safety for NPP through Generations. It will be presented by Midha Abulal. He is the third year PhD student in TPU. And finally, how to apply to study in Russia. It will be presented by Dilum Ananda, second year bachelor student from IIT NYU MIFI. So let's start. I will give the chance to Prabhat Butiga to introduce about the nuclear energy. Prabhat, the floor is yours.
Yes, thank you very much, Anshuhan. So I'm going to give you an introduction about the nuclear energy. So let's move on to the first slide. Okay, in my presentation, I will present you about 6 main topics which are related to nuclear energy and nuclear sphere. So if I explain you very roughly, as the number one first topic, what is nuclear energy and how can it be created? Second one is nuclear reactors and other applications in a nutshell. And third one is peaceful and unpeaceful uses of nuclear energy. Fourth one is radioactive waste. Fifth one is nuclear safety. And sixth one is advantages and disadvantages of nuclear energy. So let's start with our first topic. What is nuclear energy and how it can be created? So nuclear energy can be created by using a reaction called nuclear fission. I will explain you roughly about what is this, how this reaction is happening. So if we take some kind of neutron with some energy, we will bombard into a fissile nucleus and it will split into other fragments, and also it will release some neutrons, usually around 2 to 3 neutrons. So these neutrons will go and hit in another fissile nucleus and it will continue as a chain reaction. So if we talk about one reaction, it will give us like 200 mega electron volts of energy. So because this reaction is continuing as a chain, we will get like lots of energy at the end. So let's move forward. And I told you that we will talk about a bit about nuclear reactors and other applications. For example, if we talk about nuclear reactors, there can be several types of reactors according to their moderators and according to their coolants and also according to their types. So if I explain also roughly, there are like mainly 5 types of nuclear reactors. First one is pressurized water reactor, which is currently also using, we call it WWER reactor, water energetic reactor, because it has water coolant and water moderator. And one of the early types is boiling water reactor. And next we have pressurized heavy water reactor. And we also will, right now we already have these gas cooled reactors, Magnox. And also there will be some development later as fourth generation. And also we have light water graphite reactors, which used during the time when the Chernobyl accident happened. It's called RBMK reactor. So let's move to the next slide. The discovery of methane energy is actually very interesting, but in here I will explain you this Chicago pile. One is the first reactor which was made by USA, and it was the first reactor which was made in the world. It was made under the football field. And then as our number 2, we have the first commercial nuclear power plant. It was built in Obninsk. It's a city in Russia, which is near to Moscow in 1954. And the first WWER reactor, I told you early about this reactor. it's water cooled and water moderated reactor. The first one, which was built in a Russian city called Novoronezh in 1964. And currently, we have generation 3 plus going on, and mostly the reactors currently we are using is WWER reactors. So these are some photos I took during my visit to the first commercial nuclear power plant in Obnins. So as you can see, one photo is I took from the outside, and two photos I included, which are some inside figures. So let's move on to this next slide. So I told that nuclear and other applications. So nuclear is not only about power, but there are like radios, isotope productions. There can be food and agriculture uses of that, and also consumer products. And we can use in different industries, especially in medicine. When we talk, we can talk about isotopic production, also related to medicine, and we can use to for water resources and also for the environment, and especially research reactors. Research reactors, we can do some things like neutron doping and stuff. So if we move to the next topic, I told, or we as our third topic, we have peaceful and non-peaceful uses of nuclear energy. Mainly, we have military use as non-peaceful, and all other things we can say that as peaceful uses. For military use, for example, we will mostly, there are things like nuclear materials like plutonium 240 can be used to create explosive devices and bombs. But mostly every other field related to nuclear energy are peaceful uses. So for example, in medicine, we can create isotopes like iodine 131, technetium 99 metastable state, and etc. And also to generate electricity, as we told earlier. Okay, let's move forward a bit. Let's move to the next topic. So one of the most important thing is about to get to know about radioactive waste, because lots of people think radioactive waste is something very horrible, but in reality it is not like that, because we that's why we have some classification. There are some radioactive waste which we need to store under the under the uh, underground, but at the same time there are some radioactive waste which we can store in some kind of small building or something, because it all depends on the half-life and the activity of the element, uh, which we consider as radioactive waste. But the one of the main thing is that when we talk about radioactive waste is that radioactive waste doesn't mean that it's actually waste. It means that we don't need it anymore. That's why we are keeping it in a storage. So we can actually divide it into 6 types. Exempt waste. If I start from exempt waste is something that we can keep it on some kind of storage, and also very short-lived waste. That means that it has a very short half-life. So we can also keep that on some kind of storage on a ground level. So if we go to the next slide, there will be another 4 types of radioactive waste: very low level waste and intermediate waste, and also high level waste. When we talk about very low level waste and low level waste, these are also not that much harmful. But when we talk about intermediate level and high level waste, we should storage underground with some depth. So let's move forward a bit more. This is actually a waste classification scheme, uh, which you can see like according to the activity and half-life, we have some graphical representation of the radioactive waste. So let's go to the next topic. Nuclear safety. Nuclear safety is actually very important. After the Chernobyl accident, 3 Mile accident, and also Fukushima accident, people used to think that why nuclear power plants and nuclear energy is safe or not. But actually, mostly the companies who are dealing with nuclear energy, they are every time providing and also developing their safety measures. So actually we don't need to worry about safety measures anymore, unless there will be a very extreme condition. When we talk about nuclear safety, also we need to talk about non-proliferation, and it's related to safeguards, and also nuclear security. because new safeguards and nuclear security is also very important, play a very important role when it comes to nuclear safety also, because we need to make sure that there won't be any kind of stealing or sabotage of nuclear materials. So right now we can make sure that there are very safety nuclear power plants and nuclear facilities are made by the companies like Rosatom, for example. Okay, let's move to the next topic. One of the most important thing is that people think that nuclear energy is very harmful, but as other sources, as other energy sources, there are also advantages and disadvantages of nuclear energy also. First, if we talk about advantages, it's actually one of the smallest carbon footprint energy source in the world, and it's also has will give us the answers to the energy gap, because we know that we are struggling, we are having energy crisis at the moment. So it's actually one of the best solutions, and it's also at the same time it's reliable and it's cost effective. Okay, if we move to the disadvantages, uh, we have nuclear waste unfortunately, but we, as long as we are keeping it in a safe area, there won't be a big issue. And also we have to take very strong safety measurements. That's actually true. High cost and fuel availability. Fuel availability is actually a good question, because not every country has elements like uranium, but there are countries which they have but uranium. And also if we are making a power plant, for example in our countries, we can also buy from them. But initial cost, we have only initial high cost, but when it comes to operation, we can make it low by keeping and maintaining our nuclear facility. So national risks. One of the main good examples I can give you is that people are afraid of this. So there can, during an accident, for example, there can be harmful issues, but currently in modern nuclear reactors and modern nuclear facilities have high nuclear safety measures. So there are very less probability of having a very dangerous situation. Okay, so let's go to the final part of our presentation. So Albert Einstein once said that nuclear power is one hell of a way to boil water. I can explain you by using the next slide, because by boiling water, by using nuclear power plant, we are creating this much amount of energy, as you can see in this presentation, this slide. So currently, as you can see, there are like 453 nuclear power plants in operation, and also there are like around 50 under construction. So we will hope that there, there will be more and more nuclear power plants in this world, so we will be able to get through this energy crisis. Thank you very much for your attention. So if you have any questions, we will have a question and answer session at the end of this webinar. So I will be waiting for you. Thank you very much for your attention.
Thank you very much, Prabhat, for your useful presentation. And audience, if you have any questions, please be prepared with them. So after the end of the session, we will have a Q&A session. Okay, so to continue about the development of nuclear and safety, radiation safety for nuclear power plants through the generations, with the Abdullah will present. With the Abdullah, the floor is yours.
Okay, thank you very much. My name is Abu Lail Abdul Majid. I'm a senior lecturer at TPU, Tumsik Polytechnic University. I'm a third year PhD student. Today I will give a hint about the development and the enhancement of the nuclear reactor safety through generations of the reactors. Please, next slide. We will focus on four main topics. The first would be the safety of nuclear power reactors, and we will give a hint about the reactor generations and the development of the nuclear and radiation safety, and we will compare the safety or relative safety to other sources of energies. Please, next. The first topic is the safety of the nuclear power reactors. From the outset, it would be a strong awareness of the potential hazard for both the nuclear criticality and the release of radioactive materials from generating electricity with the nuclear power. As in other industries, the design and operation of the nuclear power plant aims to minimize the accidents and avoid the major consequences of these accidents to the human and the environment. And there have been two major reactor accidents. They are the Chernobyl accident and Fukushima Daiichi in Japan. So these two disasters lead to some consequences, and these are the only major accidents to have occurred in over 18,500 cumulative reactor years of commercial nuclear power operation in 36 countries. Please, next. The evidence over the 6 decades show the nuclear power is a safe means of generating electricity. The risk of accident in nuclear power plants is low and declining. The consequences of an accident or terrorist attack are minimal compared to other commonly accepted risks, and radiological effect on people of any radioactive release can be avoided. Next, please. So achieving the safety of the reactor core is one of the main concerns concerning the possible accidents up to early 1970s. Some extreme assumptions were made about the possible chain of consequences. It was not until the late of 1970s that detailed analysis and large-scale testing. So by meltdown of the 3 Mile Island accident, begin to make clear that even the worst possible accident in the conventional Western nuclear power plant or its fuel would not be likely to cause dramatic public harms. For the Fukushima Daiichi has made that clear with a triple meltdown causing no facilities or serious radiation doses to anyone, while over 200 people continued working out on the site to mitigate the accident's effect. Next, please. So the main safety concerns has always been the possibility of an uncontrolled release of the radioactive material, leading to contamination and consequent radiation exposure of the site. The fundamental principle of nuclear power plant operation worldwide is that operator is responsible for safety. The national regulator is responsible for ensuring the plants are operated safely by the license and that the design is approved. The second important concept is that regulator's mission is to protect people and the environment. Next, please. To achieve the optimum safety of the nuclear power plant, Western world operate using the defense in-depth approach with multiple safety systems, supplementing the natural features of the reactor core. The key aspects of this approach: high quality design, construction, and equipment which prevent operational disturbances or human failures and errors developing into problems. comprehensive monitoring and regular testing to detect the equipment or operator failures. Redundant and diverse system to control damage and the fuel and prevent significant radioactive releases. Provision to confirm the effects to observe fuel damage or any other problem to the plant itself. Next, please. So functionally, the three basic safety functions in the nuclear reactor are to control the reactivity, which are the measure of the criticality of the reactor, and to cool the fuel down, and to contain radioactive substance during the operation or any other undesired situation, such as the accident. Here we have the generation map for the some generations of the nuclear power reactors. Exactly, we have 5 generations. They are ranging from generation 1 and 2 and 3. We have the third plus generation, and we have the fourth generation. They are developed according to some parameters, and the main parameter is to enhance the safety of the nuclear reactor itself. Next. So here we have some familiar types of reactors. The advanced boiling water reactor, advanced Candle reactor, and advanced power reactor, pressurized water reactor, and advanced pressurized water reactor. And the main types are the PWR, pressurized water reactor, and BWR, boiling water reactor. And some reactors are listed under these two main reactors. Next, please. The first generation referred to the prototype and the power reactor that launched in the civil nuclear power. Actually, this is the early generation, and it started in USA and Soviet Union. Next, please. The second generation referred to the class of the commercial reactors, designed to be economical and reliable. They designed for a typical operation lifetime around 40 years. The most famous types of reactors listed under the generation number 2, PWR reactors and Candle reactor, and BWR and AGR. Especially the VVR reactor is the Russian type of the reactor, and this is the most successful commercial reactor type in the world nowadays. Next, please. We continued for the second generation. The second generation, we have plus 40 commercial PWRs and BWRs reactors around the world, and they are the majority of the reactors nowadays. Next, please. For the third generation, we have some enhancement according to the safety and some improvement in the design of the reactor, and improvement in the area of the fuel technology, thermal efficiency, modularization, construction, and safety systems. We are just moving from active safety systems to passive safety systems. Generation number 3, technology has aimed at the longer operation life. Typically, it's outperformed the last generation by increasing the lifetime to 60 years of operation. Next, please. So the third generation, most The most famous type is the PWR AB600. It's a 600 megawatt advanced pressurized water reactor. And this is operating in the United States. And the advanced Canzo reactor. Next, please. The reactor generation, the third generation plus. The third generation plus reactors designed are the evolutionary development of the generation third reactors. They offering significant improvement in the safety over the third generation of the reactors. Next, please. The most famous type of this reactor is the Russian type reactor VVR 1200, and this was started to design at the 2006, and after that they included some lesson learned from the Fukushima Daiichi disaster to enhance the safety of this type of reactors. Next, please. This is the last generation, the generation number 5 of reactors. They have some features over the third plus generation, as well as the ability when operating at high temperature to support the economical hydrogen production, thermal energy of taking, and perhaps even water this limitation. In addition, this design includes advanced actinide management. Next, please. Here is the one example for the most famous types of reactors, boiling water reactor, and this type was the type of the Fukushima nuclear power plant, which has the known disaster in 2011. And this type of reactor just have 2 circuits, which mean this reactors doesn't need steam generator. Next, please. This other reactor type, PWR, the pressurized water reactor, and this is VVR 1200. In Egypt, they have some progress in the work site, constructing this VVR 1200 for units. Turkey also has this VVR 1200 reactors under construction. Bangladesh also they have, and many other countries, Belarus and some reactors in the Russian Federation, they are included in the list of the VVR 1200. This is one of the most effective and enhanced safety reactors operating, and this is the third plus generation of reactor. Next, please. Here is some characteristics of this reactor. The maximum output of electricity, 1,200 megawatt. The thermal output is 3,200 megawatt. So next, please. Developing the nuclear and radiation safety, some factors were taken into consideration, including the scram and seismic shutdown, which means the reactor sudden shutdown when the reactor is scrammed automatically due to the seismic activity or due to some malfunctions, or manually for whatever any reason. So the fission reactions would stop directly after the shutdown, but the radioactive decay will continue for some time, which need to be circulation of the cooling material of the reactor cooled down till this decay heat be removed from the core. Next, please. The earthquakes and volcanoes. The International Atomic Energy Agency, IAEA, has a safety guide on seismic risks of the nuclear power plant, and the matter is dealt within the W1A page. Earthquake and the nuclear power plant. Volcanic hazards are minimal for practically all the nuclear power plant, but the IAEA has developed a new safety guide. By the way, these parameters were also taken into consideration while we choose the site of the nuclear power plant. For example, we avoid the volcanic hazards for some distance, and we avoid the floods and so on. Next, please. Flooding also are included in these parameters for the nuclear and radiation safety of the reactors. Anyway, we consider this before the site selection of the nuclear power plant, and we have some measures. These measures were taken into consideration, and we have increased these measures after the flooding disaster in tsunami, which hit the Fukushima Daiichi nuclear power plant. Next, please. So civil engineering and other measures are normally taken to make the nuclear power plant resistant flooding. And this, as I mentioned, this one of the lessons learned from the Fukushima disaster. And few parts of the world have the same tsunami potential as Japan. And then the Atlantic and the Mediterranean coast of European, the maximum amplitude is much less than the Japan. Next, please. The hydrogen is one of the most important parameters in the nuclear and radiation safety, because the Fukushima has also some lesson learned from this disaster, when the oxidation of the zirconium led to some exhausted hydrogen, and under the high temperature of the steam, about 1,300 degrees Celsius, this led to a massive explosion. It was not a nuclear explosion, but it was hydrogen fire, which led to the explosion of the reactor in Fukushima disaster. Next, please. The security against some actions, such as terrorists. Since the World Trade Center attack in the New York, they have been increased the concern about the consequences of the large aircraft being used to attack a nuclear facility. And these measures were also taken in the third-plus generation of reactors, such as VVR 1200 reactor. Next, please. The same is extended information about the scenario of the impact of the airplane from the type of Boeing 767-400 over 200 tons at the speed of 560 kilometers. And all these parameters were considered during the test of the dome of the nuclear reactor. Next, please. The VVR 1200 considered this action in the security. The large passenger aircraft impact was prevented by the double walled containment. Double walled containment is a structure protecting the nuclear reactor core, and is considered as one of the principles of the defense in depth. Next, please. This is an example for the two layers wall or the double walled containment of VVR 1200. A schematic figure shows these two layers, and also this is one of the Leningrad 2 VVR 1200. This is the containment of the nuclear power plant under the construction. Next. This is another one enhancement of the safety measure of the nuclear power reactor. This is the model of the VVR 1000 reactor zone meltdown trap. In case of any the worst scenarios which could be happen, the melt of the fuel under high temperature or any other cases, it would be melt down. The fuel would be catched directly in this trap. It would be located down the reactor core. This is one of the most significant improvements in the VVR 1200 reactors. Next. This is the relative safety to other sources of energy. As we can see, we have some energy sources such as coal, oil, and natural gas. And we compare the nuclear to these types of sources of energies. The safety is very significant in the case of nuclear energy sources. The risk from energy related to accidents per unit of electricity is much lower than the other sources. This is the statistic measures were taken at the last 40 years of nuclear reactor operations in USA and UK. Next, please. We can conclude from this presentation based on the various and other aspects, and also some are not detailed here. It's clear that only VVR 1000 technology complies the strict nuclear safety and technical requirements, which takes into account the Fukushima experience. In the UK, Friends of the Earth Commission, a study by Tyndall Center, which drew primary on peer-reviewed academic literature, supplemented by literature from credible government. It concluded in January 2013 that overall safety risks associated with the nuclear power appear to be more in line with the life cycle impact from renewable energy technologies and significantly lower than this for coal and natural gas per megawatt of supplied energy. Next. These are some references. You can just extend your knowledge by overviewing the detailed information in these references. Next. This is the first nuclear power plant in the world. It's located in Russia. It was constructed during the Soviet Union in Obninsk city in Russia. Next. These are the number of operating nuclear power reactors in the world, plus 400, and we have plus 50 under operation. Next. This is my contact. If you have any question, please don't hesitate. Thank you for attention.
Thank you very much for your useful presentations. So now I have a question for the audience. Have you got any questions to our presenters? Anyone? Okay, if there's no questions, let's move to the third part of our presentations, how to apply to study in Russia for scholarship. So, Dilum Anand, it's your chance to present forward.
Hello, everyone. I'm excited to share with you the opportunities available for studying nuclear power engineering or any related disciplines in Russia. In these slides, let's see how you can apply, of course, briefly. Yeah, so there are 5 easy steps you can take. You can choose your university or your program and learn about financing and scholarships, prepare a document package and undergo a competitive selection, and finally get an invitation. So lucky for you, there's an all-in-one website. You can easily access to all these, and it's education in Russia. And also I have mentioned the link here, and feel free to go and check it out. And here's the overall interface of the website. And here you can search about different universities and different courses as you like. But to apply for the scholarship, first you need to register in the site as usual. Sign up and complete all fields containing basic questions and submit the registration form. And you will receive an activation link to your email address, and then you can start using your personal account, and you can log in as usual as anywhere else you'll see. And then the next slide. And then you'll see my application. And to create a new application, you can click on it, and it consists of 4 main stages or parts: worksheet filling, statement filling, and document attachment, and finally sending a request for verification. As you see here in the worksheet filling, you can fill your up-to-date personal data, and then you have to save it, and then you can move on. Next slide. Statement. In the statement filling, you have to choose the type of education, what you want to learn here, etc. And here you can see I have mentioned some nuclear related fields and universities that offer them in Russia. And also you can choose up to multiple universities according to your favor. And yes, next slide. Here, as I said, you can choose up to multiple universities. These are one of famous universities that offer nuclear related subjects in Russia. Next slide. And you have to fill your achievements and extracurricular activities you have done so far. And then you can save them also. Next slide. And document attachment, here you'll have to provide your passport, educational data, and medical documents. And if you have any recommendation letters. Next slide. Next slide. Yeah, and if you have filled all the necessary fields and uploaded all necessary documents, you can finish your application, and you can click on print application, and then you can scan it, sign it, and then scan it, and then upload back again. Next slide. And then you can click on send application button. Yep, next slide. So your application was sent to the scholarship operator in your country. Most of the time it's Russian House. And next slide. And you will get a notification about its status. And depending on your country and the competitiveness, you may have to face an face-to-face interview with your Russian House. And you will receive, and that is that easy. And that's the overall process to apply to study in Russia. And that's all. And if you have any questions, and feel free to ask.
We have our social media platforms to access to more information: the RNEA, Russian Nuclear Education Ambassadors, We are always there to help other people, the international students especially, to get through all the procedures and to improve your knowledge in nuclear also. Also, there is another webinar tomorrow at the same time. So if you feel interested or if you want to learn more, you can join the upcoming presentation also. So any questions? I think no questions from the audience. In this case, thank you for your attention and thank you for attending this webinar. Thank you very much.
You're welcome.